I'm Ariel Pakes, and I'm going to introduce the empirical work that's going to be done in the next, 10 days. So, first of all, let me just say Eric's quite right in the sense that it makes sense if you were going to do one set of empirical results or one part of economics that's empirical that's related to theory, it's dominantly IO. And IO offshoots, so market design would be another aspect of this. So IO is the study of market responses to environmental or policy changes. And Eric's right, it took off, there was a change in the conceptual framework of economics in the 1970s, 1980s, where theorists introduced oligopolistic markets, or markets where each firm knew its actions affected the payoffs of other firms. Okay, what followed was a real revolution in the way theory did stuff. Okay, which is just what Eric said. Different theory. So they did two things from applied point of view that theory did. It provided a framework for the analysis, okay, and it provided a bunch of examples of what could happen, in certain situations under a bunch of assumptions. Okay. So the general goal when we came around was to build frameworks to let the data tie down the assumptions needed in order to use the theory to generate actual market responses in actual situations. Okay? So there were earlier attempts at this, which were pre-game theory, and I'm not going to talk much about them. The two really noticeable ones are a paper by Hautacker on production, which is the prettiest 5-page paper I've ever seen in my life, and a paper by Gorman on demand. The problem with these papers was it was hard to generalize in a way where you could allow for a lot of assumptions on functional forms and other things and get a result. Okay? And the generalization was needed in order to go to data. You really wanted the data to determine what were the assumptions. Okay? So what changed essentially was the computer revolution, okay, and everything that came with it. Okay, so what came with it was data, econometric techniques, computational abilities. So when I was a student, it was hard to compute a Nash equilibrium. Okay, my first paper notable paper was this paper called Patents as Options. I was at the Hebrew University doing just come back from my doctorate, and to compute it, I took down the Hebrew University Computer Center for a week. I went away to Europe. When I came back, all the scientists complained to me because I had taken down the computer. So today I could do that problem on my laptop in about 10 minutes. Okay, so it's just a world of difference. Okay, so what I want to do in the introductory lecture is sort of a helicopter tour. Okay, I'm going to tell you a little bit about the issues we have a pretty good handle on. Okay. And I'm going to review some recent developments on those issues, some extensions, okay, most of which will be done later on by other authors that are going to come up here and talk to you, okay? So I'll just sort of tell you where they're going and not tell you what they're going to do. And, periodically I'm going to return to issues which aren't yet solved, that are really sort of in the middle of what we need to know, okay? I'm going to start with what I called static analysis. So this is competitions among a given set of firms with a given set of products and a given set of cost functions. Those are all fixed, okay? And the prices I set today don't affect anything about the dynamics of those things, okay? So they don't affect anything about investment decisions or development of new products, okay? They're just static prices. So a typical issue that's analyzed here is what would happen to prices after an environmental change? Okay, so this is just what Eric was talking about. Okay, so the typical things we have to deal with are, a big thing is mergers, tariffs, regulatory changes. What would happen after we allowed a merger or we put on a tariff? Okay, the analysis I'm going to start with, it ignores the impact on physical assets, the investment decisions, and the product development. And I'll come back to that towards the end. Okay, there'll be talks about that in the thing. So I'm just going to do this helicopter tour now. So where we started, we needed some primitives. Okay, We needed a demand system. We needed to know what people would purchase at various prices for different characteristics of products. Okay? And we needed a model for how much it costs to produce those things. Okay? So the literature, I'll come back to that in a second, but so we also needed a model. So those are the primitives, and then we need an equilibrium assumption, how firms were going to set prices. Okay? So the way the analysis typically proceeded and does proceed today, okay, is you just look at a Nash equilibrium prices, which is exactly what Eric said. Okay? Typically, it's differentiated product models. I don't know if somebody asked that question. They're not homogeneous product models, and in fact, there are very few markets that are homogeneous product models. Even chemical markets for basic chemicals, the chemical facilities are in different places, so there's differential cost to get them to anywhere, and it becomes like a differential product model. Okay, the reason for going to this Nash equilibrium was that it was a rest point, just like Eric said. Okay, so if we're at a Nash equilibrium, nobody has an incentive to change its price because they're doing the best they can given what everybody else is doing. Okay, and if we're not at a Nash equilibrium, somebody does have an incentive to change their price. Okay, so it's not a rest point. We expect it to change. Okay, so it's pretty simple. Okay. So there's an issue here which we always put aside. Go ahead, shoot.
So in this case, you said about the computation of Nash equilibrium, right, in the last point. So just to clarify, so do we, from the data, we will see the prices and then say that is it equilibrium? Or
I'm going to show you. Okay, you got to wait a minute. And we're going to get to an actual example. Okay, so one of the things I'm going to do just to make it more fun is I'm going to give you a few examples as we go along. Okay? So let me note, so just so we don't screw over things, that are important, nobody believes, that I know, believes that you do a merger and you get to a Nash equilibrium right away, instantaneously. Okay? The problem is we don't know very much about adjustment mechanisms, okay, from one equilibrium to another. It's obvious that the adjustment mechanism would help you in the sense of, it would give you a transition path and it would tell you what happened in the interim. That's important, but the need for the adjustment path is more important than that. Somebody asked this to Eric. We have models with interacting agents. If agent 1 does something, agent 2 has an optimal response, and vice versa, we get to a Nash equilibrium. But if agent 1 did something else, agent 2 might have another response, okay? And we get to another Nash equilibrium, okay? One of the reasons for a need of an adjustment mechanism is it's one way you could think of selecting out equilibria. Okay? If you knew how firms actually reacted, never went straight to the Nash equilibrium, and you could simulate out what would happen, and you would actually get a rest. You would get to, if you got to a rest point, you would get to a Nash equilibrium. Okay? So this is one way of getting there. The problem is there's very little work being done on adjustment mechanisms. It's empirical. Okay, there's been some theory, and we'll return to it in these lectures, but there's very little empirical. So that's sort of a missing element of these models. Okay, it becomes much more important in dynamics, and the reason is the multiplicity issue becomes more important when there's fixed cost and sunk costs. Okay, and so it's going to come back many times in this stuff. Okay, so what did we need to do? So modulus that, I'm going to go straight to the Nash equilibrium and try and get to your examples. Okay, so what did we need to do to get to a Nash equilibrium prices in the static model? We needed a demand system, and there was a problem in using the demand systems that were in the literature. Okay, they were demand systems in what we call product space. So they were quantities of products against prices of products. So typically you're going to deal with a differentiated product market where there's 50 or so products, okay, or maybe more in autos, which we dealt with a lot. There were 200. Okay, so if you have quantity on the left-hand side and all the prices on the right-hand side, you have 50 for each of 50 equations. That's 2,500 parameters. There's no data set in the world that's going to estimate that. Okay, so that was the first problem. And the way we got around this problem is and the second problem was if it was just on quantities, okay, so how do you figure out what a new product would want? What would be the demand for a new product? And half of I/O is about introducing new products. Okay? So the way we got around this is it's an approximation, but we treated products as bundles of characteristics. Okay? So a car wasn't a car was a motor size, a number of seats, a color, whatever, 15 other characteristics, okay? Say there were 7 characteristics, and then individuals had different characteristics. Different individuals had different characteristics. Was that clear? So they like different products differentially. So, if you have a lot of kids, you wanted a minivan. If you want, okay, and so on, okay? And then you just integrated out the demand, so you had a bunch of products. So if there was, 5 characteristics and the distribution was normal, and normal was a good approximation, you had 6 times 5 divided by 2 is 30, 15 plus 6 means 21 parameters. With 21 parameters, I give you 2,500 cross-price elasticities, if I estimated it right. Okay? So that it's an approximation, but it's an approximation that worked. Okay? So this is BLP and fellow travelers. Okay? We had 2 problems which we had to analyze. One was just how do you aggregate over over 100 million people, okay? Because everybody has different characteristics. I'll be with you in a second. Let me just finish the 2 problems. And so this is where simulation techniques came in. There was data on the CPS, told you the distribution of person characteristics. You could simulate from that data set and calculate aggregate demand, and computers are good at that, okay? And it's just multiplying numbers together. So that was one thing. And then for retail products, especially, sometimes for producer products, but for retail products, there were many, many characteristics, and we couldn't take care of all of them. So if you think of a car, there's color, there's amount of ashtray. You could put 1,000 characteristics down, and then you get back to the old problem. So what we did is we took the basic characteristics and let an unobserved characteristic pick up the rest. Okay? And then you had to worry about the unobserved characteristic being correlated with price. Okay. So this is BLP's fixed point. That's what it does. Okay, it solves that problem and puts you back into instrumental variables. Okay, I'm not going to do it. Okay. Okay. So, how have we done on this? And now I'll go to problems. So, I took an example. This is a paper that's coming out in the AER next month, I think, or in the next couple of months by Tom Ullman, who was a student at Harvard. And what he did, he doesn't do this. I just asked him to do this for me, okay? And, he had to get his thesis, so I had to sign it. So he did it. So he had a very good demand system for trucks in the U.S. He was studying the bailout of GM and Chrysler, okay? And so I asked him to take his demand system, okay, figure out what the markup was. That's totally separate, okay? He estimated it totally separately. Figure out what the markup was, okay? So in the Nash equilibrium, price equals marginal cost plus a markup. The markup is straight from the demand system. You can just take it straight down from the demand system, okay? Okay, and then regress price on the cost determinants and the markup using instrumental variables because there could be a cost unobservable that's correlated with stuff, okay? So what should you get? You want to look at how well we fit, okay? This is a behavioral equation. Somebody's actually setting price, okay? And you want to look with the markup coefficient is near 1 because the theory says it should be 1, okay? So here are the answers. These were the gross weight of the truck. The cab over and the compact front and the long cab are the different ways you put on. Trucks are modular. You put on different cabs with different trailers, okay, and you put them together. And you can see the R squared is 0.86 without time damage. You put in time damage, it's 0.94. Let me just for letting you know, if you got an R squared of 0.25 in a wage equation, you'd get an article in the AER tomorrow. Okay, they've never had an R squared below 0.2. Okay, this is probably the best fitting equation in the social sciences. So there's a lot of problems in getting to it. You shouldn't get me wrong. Okay, but it's probably the best fitting equation in the social. So a little bit of it should have been expected.
Make it suspicious?
No. That's it. So let me just say, I'll tell you where. So part of it is just that the first part of this, without the markup term, the markup is within a standard error of 1. There aren't great instruments being used here, which is a reason for the high standard errors. But you should have expected part of it because the characteristics, that's what a hedonic regression is. A hedonic regression is price against characteristics. We know that did pretty well. It usually got 50 or 60%, okay? And that's why you heard about hedonics, okay? So the actual extra thing is the markup. So I asked him to go back and look over time what happens. How do we predict for a given price, for a given car, truck in this case, over time, okay? So over time, costs don't change, essentially, okay? The only thing that's changing is this demand system up there. Why is it changing? There's differential demand for trucks at different times, okay? And because there's trucks coming in and out of the market, which changes the markup. There's different competitors. If you just do it over time, you get an R squared between 50 and 60%. It's still about the highest what we ever get in economics, by a lot. And it's just through the demand system. Okay, it's just through changes in demand over time. Prices follow changes in demand and changes in competition over time. Okay, it's not perfect. It's 50 or 60 doesn't, and I said and you can see here, right? It's why it's not perfect. You put in there's only 6% missing, and almost there's 14% missing, and most of it's picked up by the time dummies. That's because the demand system is changing over time. Okay, so that's we're doing pretty well, and in fact, Department of Justice's all anti-regulation authorities right over the world are picking this up and using it. Consultancies are using it. Some firms are using it. Government agencies are using it. So now let me look at extensions. Okay. Some of these we're going to do here, and I'll tell you which ones we're going to do here, and some of these we're not going to do. Partly just there isn't enough time. There also isn't enough time to do any of the econometrics. Okay, so none of the econometrics can be done here, which is mostly what, much of what I do. Okay. I'm going to start with markets where the cost function depends on the characteristics of the purchaser. Okay. And the conditions of sale. Actually, it should be the conditions of use. I used the wrong word. Okay. So this is insurance markets are like that. Okay. So depending on who you insure, there's different probabilities of being sick. Okay. If there's different probabilities of sick, there's different costs to you because you pay the hospital and the medical groups. Okay. Similarly, loan markets are like this because there's different, whoever makes the loan, there are different default probabilities. He defaults and the cost is on you. Okay. Okay, so the extension that was required here was to allow the cost function to depend on the characteristics of the purchaser. So this is what you know in theory as adverse selection. That's how we solve it in IO models. Okay. So what's happening here is you change the price now. You're going to get different people, and different people have different costs, and there can be adverse selection. You could get worse people. Okay. And then the conditions of sale or the conditions of use, that's moral hazard. If you have a condition where everybody can go to the doctor free without a copayment, okay, the cost to the individual are different than the cost to society, and we have a moral hazard problem. Okay, so that's the other part that's got to be integrated for these problems. So I already said that this literature, it really bloomed with Liran Einav and his co-authors, Amy Finkelstein and Levin, and actually the first papers on it were on car. So Liran did mostly health insurance. Okay, he did a little bit of default, and Chapri and Salani at Columbia did insurance, car insurance. Okay, so issues that arise once you allow for this extension. Okay, is there's a possibility of market unraveling. So that's the famous Akerlof paper. Okay, okay. So and for us, that really you'll see they'll generate existence and computational issues. Okay, just the fact. Pardon?
The name should be spelled properly.
It's spelled wrong. If that's the only thing I do wrong, we're okay. So there are a bunch of issues that showed up here. Sort of more minor ones, but the ones that economists have spent much time on until very recently was sort of the fairness of contracts. Because now there's asymmetric information. The firm doesn't know the characteristics of the individual, and the individual might not know as much as the firm does about, what's likely to happen to your health of a 65-year-old who lives in Florida, and so on. Okay. So there's a Department of Insurance in almost every state in the United States whose job it is to make sure contracts aren't too unfair, okay? So rates have to be submitted to this Department of Insurance. In healthcare, you have to have hospitals that cover the network appropriately and so on, okay? Actually, the bigger impact of this that's affecting us now is sort of through social norms, okay? So, you know, we live, at least in most of our countries, in contractarian societies, where a citizen who fulfills, you know, its duties has a right to a certain minimal level of goods and services. And we've decided in most countries, including this one and including America, that those services include health insurance. Okay? And it's a little bit different than all the other markets because the object of the economist in this is not to maximize welfare. Okay, this is not the idea. We're not trying to send people to hospitals that have steaks and gold-plated plates and everything else. Okay, we're trying to give a minimum level of goods and services we've decided what they are at minimal cost. That's the goal. Okay, so it's a different objective function, and it results in different kinds of policies. It's also resulted in, because it's a contractarian society, it's resulted in governments entering the market, and there's a question of market design. Okay, so this is a big issue in the United States right now. Okay, this is what Obamacare was all about, and this is what Trump is trying to change. Okay, but it's raised a set of issues for IO economists and health that have been a large part of research recently. Okay, so I said it's going to be like a helicopter tour. That's what I'm going to do on insurance. Okay, so the second extension is on vertical markets. This is what we're going to hear next, okay, and a little bit after that. So vertical markets are typically markets where there's two levels. There's an intermediary in the middle of these two levels. What the intermediary does typically is contract, I'll give you an example of this, is contract with other firms on the top. So in healthcare, it would be the intermediary is the insurer. Okay, he contracts with various service providers, hospitals, medical groups, and everything, okay? And then the insurer sets prices in the downstream market, okay? He sets prices like National prices, okay? Ali will probably go over TV, which is similar also. If in the upstream market, if both the insurer and the healthcare providers are large, okay, there's typically a bargaining situation that's going. There's a contract set in a bargaining situation that's going to go on. And this is bargaining with externalities. So the basic paper on this was by Ali and Greg Crawford, the first paper. Okay, and Ali will be talking here. Mike's done much of the theory. The examples of these markets that have been used, that probably will be used here is TV, which is content providers, are the upstream guys, okay? They sell to cable channels, okay? The cable channels put it together in a tier and market to you, okay? Or health, which I just described, and you know, manufacturers and large retail, Walmart doesn't just accept prices, okay? It bargains its prices, okay? The total profits generated by the contract are the costs of the providers and the revenue of the retailers, okay? And what the bargaining does is it splits those profits between the two agents, okay? This is where one of the places where theory comes in. There's no generally accepted notion of a rest point for these models. Okay, the real problem is what's the deviation? When you do bargaining models, it's you know, what I get if I am bargaining and what I get if I wasn't contracting with this guy. Okay, and what I get if I wasn't contracting with this guy is a counterfactual. Okay, and you have to decide what would happen were something to happen that you don't observe. Okay, and that's where the issues are. It doesn't mean, you know, so there's still issues. We've solved is the wrong word. We've started work on them, okay? We've gotten quite a fair distance. I'm going to give you an example now. So I'm giving you an example when you forget about the intermediary, okay? So this is, I was on a panel, and this is taken from this panel, okay? So these are the two industries that most of the work has been done. Content providers, so for TV, okay, and they sell to cable channels or Dish or DirecTV, and who then market as a tier and sell to consumers. And this is just a healthcare example. So I'm going to give you an example, okay? So this is an example. It's just sort of fun, which is why I chose it, okay? This is actually happened, okay? This was a class action suit against Major League Baseball, okay? So what's going on in this thing? There's different teams. The teams have regional sport net. Teams have a home television territory, okay? And they market their stuff through a regional sports network, which, by the way, I think Ali will tell you, is probably the most profitable program on TV, okay? That's what people care about, okay? So the in-market telecast rights, so these are all markets where the teams own the rights, are assigned to the teams. But if you want to go out of market, so if I'm in Florida and I want to watch the Yankees, which is the New York team, for those of you guys who haven't, I'm not a big baseball fan, by the way. The out-of-market telecasts are held by the league, and none of the teams can sell separately. So the Yankees cannot sell in Florida. It's illegal, okay, or they wouldn't be in the, okay. These are sold as a part of out-of-market bundles. So the only way, if you're sitting in Florida, the only way you can watch the Yankees is to buy the whole bundle for all teams, okay? So the class action suit said, this is dividing up territories. It's illegal. It's a cartel. Okay? Okay, that was the case. And they claimed that, this was, harming all the consumers, particularly the ones who bought the out-of-market bundle, because they had to pay higher than, they would have had to pay if they just want to watch the Yankees. Okay? So, again, this is exactly the kind of market. There's these total profits, which are split between the content providers and the MVPDs, okay? The downstream market, so up here there's bargaining between the content providers and the MVPDs. And then in the downstream market, the MVPDs, which are the cable networks and Dish and DirecTV, they just set national prices, okay? So Knoll, the way this guy Roger Knoll did this, okay? Knoll took a simpler model, okay? He took this model where costs equal the telecast costs, okay? The cost to the cable network were the telecast costs. Each RSN sets its price to its consumer for its own product, okay? And maximizes price. So he envisioned a market where each team owned its RSN and sold across the states, all of the United States. Okay? That's not what happens. Okay? What happens is there's negotiations between the RSNs and the cable network. The cost isn't that cost. The cost is the telecast cost plus the markup, which is their profits, the team's profits. Okay? The MVPDs then, they sell the whole bundle of RSNs to the consumers, not just one, right? It's going to be the cable network and your Verizon, whatever, in your Comcast, okay? And they're going to set a price for the whole bundle, okay? Not for one, okay? So what happened was, when you actually did the model correctly, the MVPDs set a higher cost than Dr. Knoll assumed because there was a markup term. And when they did the multiple products, okay, so then they understood that if they increased the price on one product, okay, and people left, they would go to the other product. They might watch Milwaukee instead of, okay. So that will keep prices higher yet, okay, because the whole thing about pricing, right, what happens when in the Nash price game? The Nash price game is very simple, really. You increase the price by $1. You keep $1 from everybody who sticks around, okay, and you lose the markup by those who leave. Okay, because some leave and you had a markup between price and marginal cost. You keep on increasing price until that's equated to zero. So that's what's going on. Okay, but now if I own both products, okay, I increase the price, I get $1 for all those who stay. And some of those guys who leave, I don't lose anymore because they go to my other product. So prices go up higher. Okay, and when you did this, okay, the Knoll analysis unraveled. Moreover, he didn't check equilibrium conditions. And what happened here, that's the other thing you always have to do. So, there's a question. Say we changed it and we let the RSNs do it. There's a question, and there was still going to be an out-of-market bundle, and the whole analysis of Noel was the price of the out-of-market bundle would go down because it'd be competing with more stuff, okay? But what actually happened is the Yankees wanted out once you did this, okay? They could do better on their own by just marketing their own to their own goods, okay? And the whole thing would have collapsed, okay? So they killed the case. But this is an example of just how important it is to get the structure of the market right. Okay? They lost the case because of this. Okay? Okay. Oh, yeah, questions.
Was the correct analysis introduced in the case itself?
So what happened in the case itself is one side, what they did is they lifted one assumption at a time, okay, and showed that if you just lifted that assumption, like the marginal cost assumption or the pricing assumptions, the analysis got skewed. If you let the Yankees leave, they would leave, okay, and that was enough to convince the judge that it was all over. The other side had no response, so that was it.
And who was presenting the other side?
Guilty. That's why I know all this. What? I'm not sure. Let me just say, I'm not sure it was right. What I'm sure is what Noel did was wrong. Okay, I mean, I'm not sure what the actual answer should have been if it would have been done right. Okay, I think
it's conceivable
that if you put it all together, yes, that's exactly right. And I never argued that on the stand. Okay, I just argued that what they did was wrong. Okay. So that's two examples now of extensions. One was insurance markets and one was vertical markets. There's another example of extensions that's going to be done here. Okay, the insurance markets aren't being done not because they aren't important, but more of it's sort of been done in the literature. Okay, and so there were less open questions. But if we had more time, we would have put in insurance markets, I promise. Okay, but there is going to be vertical markets, which is next. Okay, and the other one is going to be non-price centralized allocation framework. So this is really a market design question, but it's been attacked by IO people, at least empirically. Okay, so the people who will talk about that are Nikhil Agarwal and Parag Pathak. Okay, so they'll be here next week, I guess, talking. Okay, so this is how medical residencies are allocated. So medical residencies are doctors who just got their doctor degree and want to do a residency to become a specialist. Okay, so this was Al Roth's initial thing. School assignment, and this is how kids get allocated to schools in Boston, New York, London, Chicago, increasingly everywhere. Okay, and now they're starting on the kidney match. Okay, so the framework, I'm sure Parag will go over this in detail. He just won the Clark Award for this. Is a framework by Gale and Shapley called the Deferred Acceptance Algorithm, either one or top trading cycles, depending on which one they are using. These are frameworks that will tell you how to allocate. Okay, they have particular theory problems associated with them. So they have a particular structure associated with it, which doesn't match reality exactly. Okay. And so where the empirical people came in, and partly the theory came in, okay, is to start with the theory coming in, is how to modify the deferred acceptance algorithm, or the top trading cycles, usually deferred acceptance algorithm, to allow for deviations. So I'm sure Parag will talk about this. So in the school system, for this to work really right, okay, you have to give a preference ordering for each school. If you stop at the fifth school, it's not necessarily a good it doesn't satisfy the conditions of the deferred acceptance algorithm, and therefore is not either necessarily incentive compatible or necessarily get to a stable design. Okay, so I'm not going to go over too much of this, but that was one issue. There's ties and orderings because, kids have the same ordering and going to a school. Many kids have, an A-class record, okay, going to that school, and they're from the same walk zones. There's interdependent preferences. When women and men are married, they're both doctors, they want a residency program. There's a lot of other issues. There's been an issue of orderings of mechanisms by manipulability. When I say incentive compatible, what I mean is when I write down the list of what I want, it's incentive compatible for me to say the truth. Okay? That's no longer true for all of these once you take this away. Okay? So that leads to a question of what the allocation is, and it leads to a more important question of how to analyze the allocation. Okay? Because when people tell you the truth, I can estimate utility functions. Okay? When people don't tell you the truth, I have another issue. Okay? And then there's equity issues. Okay, so the empirical work on this, so this is where we came in, at least most of it has been done on either the medical school match or the school match. The medical school match, the problem with it was you didn't really see the lists. Okay, all you saw was the final allocation, and you knew something about the characteristics of the individual. So you knew which was the most desirable hospital, you knew who had the best grades, okay, and you had to match the two. So it comes very much like our demand system allocation systems, where you want to match people to schools. So what typically happens in the deferred acceptance algorithm in this part of it is the best guy gets to choose his best hospital. Is that clear? The second best guy gets to choose among the less opening hospital, and so on, okay? So you have to estimate, what is the best guy as a function of his characteristics, and what is the best hospital as a function of their characteristics, okay? And that becomes the estimation problem, okay? In the school match stuff, there's just the best data I've ever seen on demand, though they seldom use it all, okay? Because you have an entire list of what the kid wants, okay? So, you can say it's observable characteristics, the kid, I don't know, he comes from a certain area, he has a certain kind of parents, and so on. But there's also unobservable characteristics. Is that clear? There's things you don't see. So the kid's from a poor area, okay? He has to go home at night. His mom is working. He wants to go to his grandmother's house. His grandmother's house isn't in the same location as his own house. But I don't know that he has to go to his grandmother's house because that's not on my list. But what I do see is that his first and his second and his third choice are all in zone C, where his grandmother lives. Is that clear? And the extra choices give you a phenomenal amount of data. Okay? For I/O, if you get 2 choices, you're doing great. So in the auto, when we first did our auto stuff, General Motors, they put a 64,000 person survey every year. It was done by J.D. Powers. And the big innovation was they asked your second choice. If you wouldn't have bought this car, okay, what car would you have bought? Okay? And that helped us dramatically. That just changed the whole game. Okay? Here they got, 100 choices. They don't really have 100 because they stopped. They put in 6 or 7, but there's an amazing amount of data. Okay? And you can do a really good job if you do it right. It just takes time. That's part of the problem. Okay? So I'm sure the other issue that comes up here is you want to compare to the other choice, what's called the Boston School Choice Mechanism, which was crazy. They'll explain it to you, but it didn't make any sense at all. But you still have to compare to it. It's not incentive compatible. So you needed a way of transferring people's lists, okay, into utilities so I could compare what was before to what was after. Is that clear? So you needed a way to estimate this when the lists are not incentive compatible. It's one of the things Nikhil Agrawal did with Paulo Someni, I think, in a paper. Okay? And I think Parag's name may be on it too. I'm sure they'll talk about it. Okay, so that was another issue. And then the other big issue in this was, you're never going to get all of the conditions of the deferred acceptance algorithm accepted, in any market. So the question is, what's the important aspects? What do you need to do in order to get the benefits of deferred acceptance, okay, given the constraints of the person making these decisions, okay? So, I'm sure they'll talk about that too. And there's a paper now by Parag, and I think Nikhil which does this very well in the AR just recently, I don't know, maybe two months ago or something like that. So they'll talk about that, okay? So I'm giving you an introduction more than, okay? The kidney match is slightly different than these other two. The kidney match is different because it's dynamic. You need a kidney, okay, and you get offered a kidney. You can reject the kidney, and you might reject the kidney because it's not such a good kidney, and you might think a better kidney is coming along the path. Is that clear? And they do reject kidneys. You know, people do reject kidneys, okay? Older people's kidneys are not as good as younger people's kidneys, and so on, okay? And so the allocation mechanism has to be dynamic, okay? And it has another complicated part of it, which is, you know, not everybody can use every kidney. You have to have a blood match. You have to have other matches, okay? So not every kidney that appears is good for you, okay? So there's a dynamic problem with, you know, characteristics interacting also in this model. Okay, so they'll talk about that. So you can look forward to that, okay? So that's one topic. I'm after 12:35, but Eric told me originally it was 20 minutes.
Well, we're going to 12:45.
Okay, I promise I will pass that also, but not by much. I'll try not to, okay? Okay, so that's one side. That's the demand side and extensions to the demand side, okay? I'm going to talk a little bit about production functions and productivity. Let me say that had we more time, this would be the one topic I would add to the list of topics that are being discussed. Productivity is just the ratio of output to inputs. Okay, so one firm with a fixed number of inputs gets more output than the other firm. That's productivity. It's more productive. Okay, it's been central to I/O because of regulatory issues and because of mergers. Okay, so the relationship between market structure and the efficiency of the allocation of output of firms is a traditional question in I/O. It shows up in mergers, both vertical and horizontal, okay? And it shows up in regulation. That's the reason for regulating monopolies. It's also important for the evaluation of policies for infrastructure. You want to know what was the productivity effects of putting in infrastructure or public R&D or intellectual property, and you could go on. That's why there's such a huge literature on productivity. The issue that arises from an applied point of view was estimation of the index of inputs, okay? So there's more than one inputs, okay? We call that index the production function, and we try and estimate it, okay? Productivity is the residual in this, right? So if I know the inputs, okay, the residual becomes productivity because I get more, if I have more residual, I get more output for the same amount of input, okay? So typically, I'm going to give you an example of this in a second. Environmental change, you know, strong environmental changes or big environmental changes relative productivities of firms. Okay, so if you're going to analyze how it changes productivities, okay, it's going to change different ones differently. Small firms will exit, you know, quicker than big firms. Okay, so because big firms already have more capital in place. So if you see, so what's going to happen is if you look at a balanced panel and you don't take account of the exit decision, okay, the guys who leave will be disproportionately small firms, okay, so there's a selection problem, and you'll get the wrong coefficients of the production function because you're just selecting on those guys who had high capital and, okay, and low productivity, so that's going to give you a selection problem. So you had to correct for entry and exit. Moreover, the firms whose productivities grew because of this, okay, are going to add more inputs, right? They're just going to go down their marginal revenue product curve. They're going to add more inputs, okay? So the productivity term is going to be correlated with inputs, okay? So the econometrics had to take care of this. The way we did it is we looked for the theory which told us what the relationship was between exit and productivity, or exit and state variables, productivity and capital and whatever else was in the thing. So that goes back to the Maskin and Tirole articles, which were sort of, Eric went over at least one of them. You don't realize this, but you just saw Maskin Tirole 1, parts of it anyway, a large part of it, in your original lecture.
But next week.
You'll see even more. Okay. So, I mean, a lot of what Eric said is my students have to read it in Maskin Tirole 1. And then Steve Ollie and I figured out how to do that in a non-parametric way in production functions. Let me give you an example of just how much this matters, so you get an idea. So I don't know, how many of you have heard of American Telephone and Telegraph? Yeah, it's about, you know, when I was a student, there was a paper about AT&T, and Mike Spence was in the classroom, and somebody said, you know, this firm, and Mike said, no, this isn't a firm, this is a country. It has 1 million employees. It acts like a country. It was huge, okay? And it had a legally, you know, it had a monopoly right to providing telephone service because it put the cables in the ground. It said it's costly to put the cables in the ground and get into your house. We won't do it unless you give us monopoly powers, so they had monopoly powers. So it got broken up in two pieces. One piece was just you were able to connect things to the public network, to their lines that they drew, okay? So this was good for like local, for connecting between 2A things. And then finally in 1982, this Judge Green broke up American Telephone and Telegraph and broke it up into 7 regional operating companies, and none of them could could own an equipment supplier. Because what AT&T had done, okay, is they only bought from Western Electric, and Western Electric was their own company. It was a wholly owned subsidiary of AT&T, and the judge didn't want that to happen, okay? The industry changed dramatically right away, okay? So as soon as this happened, Ericsson, Northern Telecom, Hitachi, everybody entered the American market. There were 7 firms which have changed 15 times around, okay? I just want to give you some idea of what happens if you don't take care of things, okay? So this is the estimates before we came around, the I/O group came around. People used to use balance panels. So you just kept all, because it was difficult to know what the exit was or the entry was, you just keep all the guys who were there all the time and you estimate a production function, okay? So if you did that in this case, these are the census data, you would have gotten 896 observations out of 2,600. You threw out 2/3 of the sample. Okay, and not, you know, this is a select 2/3. Okay, this is the 2/3 that it didn't do well, and then you just analyze the guys who did well. Okay, and then if you looked at the selection problems, you started out with, depending on whether you total and within, this is just within, everybody knows what within is. The theorists probably don't. So in social science, in general, this is the most basic division in statistics, okay? If you look at any unit, firms, people, whatever you like, okay, the differences between them across individuals, and you look at the determinants of that, that's one thing. That's called between, okay? And then there's within, which is differences within an individual over time or within a firm over time. That's called within, okay? You'll always get a huge difference between the two of them. It doesn't matter how you do it, okay? I've never seen a data set that doesn't get different results, okay? So we did both total and within. You get a little bit difference, but when you go back to after doing this correction using Maskin-Tirol and Ollie-Pakes type stuff, it goes from 0.851 to 0.608, and the capital coefficient doubles, okay? So you get very different production function estimates, okay? You know, you're using all the data now, you're not, okay? And you can start analyzing productivity in a richer way. By the way, let me just say, this was one of the first papers that, and this is one of the data things I was telling you about that changed, okay? So we actually had access to microdata. Almost all the productivity stuff that happened before this was just aggregate data, you know, an industry's data over time. Okay, so think of the difference for I/O. I can now ask whether the allocation across firms is efficient, which was the basic question in the first place. Is that clear? And you couldn't ask it before. Okay, so that's just a data thing. So the easiest decomposition is this one that we provided, which is this is just the share weighted average of productivity. So it's average productivity. Is that clear? And you can divide it into an unweighted average and a covariance term between shares and productivity. You want the best guys to produce the most. Okay? So it divides it into an allocation effect and an aggregate productivity effect. There could be technological change or whatever else you like, okay? So I'll show you what happens. So this is the telecommunication equipment industry. So this is Western Electric, starting out just Western Electric, and then it changes, okay? And Western Electric has many plants, okay? Western Electric, when this happened, whole cities went under, okay? Because Western Electric, they were doing all this stuff that wasn't electric, okay, that was, you see on TV things, okay? The machinery just wasn't. So they closed down plants. Plants in this case was, 5,000 people in a small town somewhere, okay? So, and they were out because as soon as Hitachi and Northern Telecom could come in, it was all going to be done by computer, immediately. This is a huge thing. So you can see productivity goes. So this is when their certification program came in, where you could start attaching things to the network. Productivity starts going up, keeps going up until the judges claim in 1982, and then a lot of things change because they have to switch. They're closing down plants, they're opening up new plants. Productivity goes down again and then starts going up again. Okay. Moreover, you can see what the difference is. This is just the covariance between capital and productivity. When it started, the most productive firms were the smallest, okay, which is exactly the opposite of what you want, okay? And then gradually it starts getting better, okay? Because, AT&T kept these old plants, it kept the old stuff. There was no need to change. They weren't going to buy from anybody else, okay? And once it started coming in. So, okay, so that's the example. Let me just say let me now go back to problems with this for a second, okay? So most of the data sets, including the one I just showed you, have revenue and not quantity. Okay? So I'm giving you revenue productivity, okay, and not quantity productivity. That's a problem, right? Because sometimes you want it, so productivity, revenue can go up because of price or quantity. You want quantity to go up but you don't necessarily want to count price increases as a good thing. Is that clear? And in fact, if you come back here, there probably was productivity change here. More productivity, more average of productivity change. But one of the reasons you probably didn't pick it up is there was more competition and prices went down. Okay? After that. Okay? So, the next stage in this should be to have separate price and quantity equations for these things and then analyze productivity. So this guy, Jan de Locker at Leuven, he used to be at Princeton and left, has started to work on this. And there's some work on it. He can do it in putting on enough assumptions. By the way, let me just say, if there was one more topic which I would do here, this would be the first one. Okay? He puts more structure on the input decisions and can do it. Let me say there are real issues that aren't being analyzed here. So there's no many of the firms in the United States are multi-product. Okay, they're producing many things. Okay? Including hospitals, by the way. And data limitations means that I could go into this in detail, but I'm not going to. It's virtually impossible to estimate a cost function. Okay? And if there's no cost function, it's a multi-product firm. There is no production function for a single good. Okay? It's by definition, right? Is that clear? Okay. You're producing multiple goods. Okay? So it's a map. There's, for a given amount of inputs, I can map into different combinations of output. It's now a correspondence and not function. And so, we should be working with production possibility frontiers. I've never seen anybody have done that. Okay, and it's going to be important for both economies of scope, but also for vertical integration. Once we get actually analyzing vertical integration, because now the different parts of this, okay, are producing different things. Okay, and there's going to be common costs. Okay. So that's one aspect that hasn't been done. Again, we go back to the dynamics, and there's a huge amount of things of R&D on productivity, and it's really been, first of all, it's been the major issue among a bunch of merger cases, like the two recent ones are Dow DuPont and Monsanto Bayer, where the whole discussion was about how the R&D facilities would compete or not compete, okay, after the merger, okay? And actually, at least in Dow DuPont, which is over, I had nothing to do with this. They forced them to sell off all their agricultural chemical parts. Okay? And then, there's this current debate going on about concentration in the United States. Concentration is rising. Profits are rising. It's not a very academic debate, let me just say. It's not a very careful debate. Okay? But what's underneath it largely is the R&D stuff. It's, why is Google ahead of everybody else? Why are we getting very big firms? Okay, they're developing things, and there's a question of how I do how I'm really going to analyze this in detail. Okay, so much for productivity. Okay, so I'm going to slowly move into dynamics, and I will be this won't take me much more than 5 or 10 more minutes, okay? So the one part of dynamics that we've made a fair amount of headway on is what's called product repositioning. So in the literature, product repositioning is you change, it's the same firms are in, it's not an entry of a firm. It's just changing the location of its products. Okay? So, it became a big deal in merger analysis. The reason it became a big deal in merger analysis is there's a few people, and I'll show you an example in a second. Merger analysis, what it's done, because dynamics are so hard, this is wrong about merger analysis. But what's being done at the FTC and the DOJ and the Israeli Merger Authority is they're focusing on the price effects, okay, of merger. The one I just explained to you, okay? And there's 3 or 4 papers now that have shown that industries can just as easily change the characteristics of their products, okay, as their prices. Is that clear? So, so you want to know how that might happen in response to the merger. So this requires estimates of the fixed costs. So there's so the only addition to this is I need to know the profitability, with one tuple of characteristics and the profitability with another tuple of characteristics. If I have the demand function and the cost function, I can do that. But I also need to know the fixed cost of putting in the new product. Okay? So, there's been an analysis of this. We've actually made a fair amount of progress on this. Because all you do is once you have the profits, if you can compute the counterfactual profits, and you look at the products that were put in, is that clear? The difference in profits between having the product and not having the product, which I can compute now, okay, has got to be at least on average greater than the fixed cost. So that gives you a lower bound to fixed cost. And then you can look at things that they didn't put in but could have put in and do the counterfactual. And that's got to be less than the fixed cost. That gives you an upper bound on fixed costs. And if you knew how to do the econometrics of moment inequalities, which is something we would do in an econometrics course, okay, you would know how to analyze this, okay? And it's been done now, okay? So I'm going to give you an example. It's always fun to look at examples. So this is a true example. This is Intel and AMD producing chips, okay? This is a paper by a guy named Chris Noskow, who unfortunately decided to go to Amazon and make money instead of being an academic, okay? Which has happened now to 2 of my students. Which is really, you invest all this stuff, but I guess it's okay. So the red dots are AMD. What? Yeah, it's also part of the economics of making money. So it depends on your utility function, right? We could estimate it and figure out where you're going to go, and I didn't do that. The red dots are AMD, the blue dots are Intel. This is June 2006. In July 2006, Intel puts in the Core 2 Duo chip. Okay, this Core 2 Duo chip, you guys might know it. Okay, the Core 2 Duo chip just swamped everybody else. Okay, so you can see in July already. So what's happening here? There are 6 or 7 chips, including Intel's chips, between 600 and 1,000, selling at between $600 and $1,000. Is that clear? Okay. So Intel comes in with the Core 2 Duo. They immediately drop out their intermediate goods. Okay, and then within 3 months, this is what it looks like. All the intermediate goods are gone. Okay, all we have is Intel. Okay, it threw out its intermediate goods. Okay, charged a huge markup on these goods. If you went to a year, there's nothing but the Core 2 Duo left up here. Okay, charged a huge markup on the Duo chips, and that's how they made their money. Okay, so let me just say they were talking about an AMD Intel merger. If you would have analyzed it conditional on product characteristics, you would have gotten things terribly wrong. Is that clear? Because if AMD and Intel merged, they would have done exactly the same thing. He did that, okay? They would have just killed all the intermediate and then charged a higher price. Now, there's still a question whether that's good or bad, because the reason Intel can do the research is it earns its money from these, when it puts in a new chip and it can make a lot of money on it. That's what does the research. Okay, so there's a dynamic question of what's good and what's bad. I'm not going to get into that. But if you would have analyzed the merger without this, you would have done terribly wrong. Okay? Question? No? I've been going too fast and too little questions, but we're here for 10 days. So. You can do it. So dynamics, this is it. This is my last topic, and I'll be short on this because there's going to be talks on this. So Eric's going to talk on this, Myrtle Calypsody, and I'm going to talk a bit. So we need the part that's left, except for is we need a model for an empirically usable model for investment in physical assets, okay, and in product development, okay. So we started with these Markov perfect models. You know, you can go back to Maskin and Tirol, or the empirical framing that was used was by Rick Erickson and myself. So it's pretty simple. Firms make choices to maximize their perceptions of the expected discounted value of future net cash flows, okay? And their perceptions are consistent with both the play of competitors and the process generating any exogenous factors. That's essentially what Markov perfect means, okay? So, you know, this model, which we've worked intensively with, it's been helpful, you shouldn't get me wrong. It's been helpful for computational theory. There's been a lot of computational theory. And there's been a bit of empirical work, notably a paper by Lanier, Benkard, and Gertler and Gordon, okay? But we ran into real problems when we started using them more generally. You know, when you took into account what you thought were the right variables, okay, the right state variables, the right things that I condition on every period and then invest in, okay? You got huge state spaces, okay? And unrealistic requirements of both the agent and the researcher to compute things. So cognitive requirements, if you like, okay? So it just shouldn't get me wrong. They still might be the best model available at the time, okay? But the cognitive requirements were such that you thought that maybe there was a different model that would be a better approximation to reality. Everything we do in empirical I/O is an approximation. You can forget, you know. The question isn't whether you get it right. The question is, do you get it better than the next best guy? Okay, because you're never going to get it right. It's too complicated. That doesn't mean you don't know more than the regulator, okay? But it does mean that you should expect errors, okay? But the case here was strong for maybe trying something else. So there have been a couple. One actually comes from OR. It's based on just approximating the equilibria. So these equilibria are Markov processes. They're Markov process on what's called counting measures. So it's just a process. So let's say we're just doing capital, okay? So a counting measure is just how many firms with capital stock 10, how many firms with capital stock 15, 16. Is that clear? So the equilibrium, what it would generate is a distribution of counting measures tomorrow given the counting measure today. Okay, that's the Markov process. Okay. So instead of doing that directly, this paper by Benkard, Weintraub, and Van Roy looked for the limiting measure, which is called the invariant measure. So, you know, you hit certain points in this process, you'll hit certain points repeatedly, and the probability of hitting those points. And so instead of taking where you are today as where you are, they take the limiting measure as where I'm going to be tomorrow. Okay? And then there's another approach by Chaim Furshman and myself. It's called experience-based equilibria. And all it assumes is that given firms information sets, they don't err on average. Okay? So they might err, you know, periodically, but they don't err on average. Okay? You know, this can nest oblivious equilibrium with appropriate information sets. And it's very similar, although in a different context, as Fudenberg and Levine's self-confirming equilibrium for the theorists. The difference is we're working in a state space. We're not working in a repeated game. We're working in a state space that evolves over time with investments, but some of the concepts are very similar. The empirical work on all this stuff is just beginning, and you know, I think the best paper is Myrto's paper, who's going to be here to give it probably, okay, which combines these two things and actually looks at trade policy. Okay, it's really quite a paper. In settings with search and endogenously determined trade costs. And then she finds out what happens if China goes under or there's tariffs on China or the Northwest Passage changes. And all the trade, she gets all the trade in the world moving around. Okay, and she will show you how to do all of this when we get to the dynamics. So that'll be the last topic we go over. Eric will go over part of it, and I'll go over part of it, and Myrtle will go over part of it. That's it. That's all I have to say. That's a lot, but it's sort of trying to be an overview. Okay?